Well, how do you say? Buongiorno a tutti. Hello, everybody. So that's probably all the Italian you're going to hear from me today, because I never got the chance to learn your language. I very much like the sound of it, but I don't understand very much of it. Well, I was actually hoping to be in Pordenone with all of you, but yeah, we have to take what we get. Right, so this is the first Data Saturday, although it's the second in the calendar. Well, welcome to this session called POM and SQL Server Monitoring. My name is Thomas Hütter, and you see on the screen down there, we got the sponsors of this event lined up. So even a virtual event is not possible without sponsors. So give them a chance, take a look at their products. They're probably very useful things for you today. Right, usually my slides look like this. That's the old SQL Saturday design. And so we continue. Well, briefly about myself, Thomas Hütter. I have a degree in business matters, but I have been an application developer for most of my professional life. And also sometimes a consultant. I'm the accidental DBA, and I'm author of a couple of articles. I've dealt with SQL Server since the version 6.5, quite a long while ago. My daily job is to mingle around with the software that was formerly called Navision, which is now Dynamics 365 Business Central. Maybe next year it'll have another name again. And I've been, well, playing around with the R language since version 3.1 point something. That's about 5 years ago. As a side gig, I don't really do anything big in production with it, but we'll see about that later. Also, I'm a speaker at SQL and data events, mostly around Europe. You see some of them lined up down there. And there's my social media data. If you want to stay in touch, please go ahead. Okay, so what's this session all about? First, a bit about my background and the motivation for this session. How did it come to be? Well, we'll take a look at the system databases. This is around the SQL Server jobs and jobs monitoring, so we'll see where to find the relevant data for that. I'll introduce you briefly to the R language and the IDE, and then we'll take a look how to gather and prepare data in R. Next up, doing some visualizations and the little trend lines. Finally, we're going to bring it all to the SQL Server. That's a bit different than doing it in the integrated environment. And yet I have a roundup, some follow-ups to tell you I'll share my resources, and we'll probably have time for question and answers. Okay. Right, so the background. As I said, I'm mostly a software developer, and my tasks, of course, are developing software. In my case, modifying the Business Central. We have about 600 licensed users in our system, and it's, of course, heavily modified and then individualized. So we are at the moment 5 software developers just dealing with the ERP software. That you document your changes. Of course, you have to support the users. The usual, sometimes silly questions come up. We design interfaces to other systems, and with that comes the SQL Server in the back end. It comes into action. You have to develop use and store procedures and SQL report and all that stuff. And as I was the one who said, yes, I know about SQL Server, I'm also tasked with the accidental DBA role. Because we are a rather small team, we don't have a dedicated DBA person. So that's shared. The more technical part is done by an administrator, and if it comes to handling the SQL Server, doing some developing around it, it mostly ends on my table.
Sì, assolutamente, anche perché,
So
cioè, ripeto, il
I have
servizio è
to
buono,
analyze
però
what blocking and
queste
blocking
piccole
occurs
tattiche
and
commerciali
optimize query
fanno cadere un
performance
po'
and
il
so on.
castello di buone
There's someone
intenzioni che si
who's
sono
not
dalla vostra
muted their
parte,
microphone.
quindi
Hello?
prendo atto e poi alla fine dei miei 2 anni dove sono costretto a stare o evitare di pagare penali, valuterò il caso di rimanere o cambiare
To
come
change
metodo,
indexes, you update
verso di
statistics. That's
diversificare.
one of my favorites. And of course, you create and have to monitor the SQL Server agent jobs. Okay, SQL Server agent jobs. What are they? Wait, they can contain one or more steps and then doing like administrative tasks like database maintenance or data manipulation, even importing
Sì, sì,
SQL.
però l'utente non si deve sempre sentire,
You
l'utente non si
actually
deve
can run
sentire sempre preso
SQL
in giro,
scripts.
perché
You
se fosse
can
arrivata il primo
SSS
gennaio, che dal
packages,
mese
or you
prossimo
can run commands even
magari
for.
avrei sboccolato lo stesso, però sarebbe stata un'operazione corretta da parte vostra, perché le cose possono,
Leonardo,
danno
can you mute
fastidio.
your microphone?
Un euro in più di far finta di niente, uno si sente un po' preso in giro, capito? Quindi mi auguro che dal prossimo aumento, che
What do you
sicuramente
think
ci sarà
about
se
it?
io sono
Rather
ancora con voi,
irritating.
l'aumento di febbraio 2022 sarà comunicato a
Okay,
gennaio
so
2022.
yes, agent jobs can be run according to schedule in response to alerts.
Ok,
So
grazie.
some condition is happening within the SQL Server, or you can fire them manually, no problem.
Esatto,
Those
sì.
are the ways that they can be invoked. Yes, that's a snapshot of our live system from some time ago. We have like 20 odd jobs running in the production system. Some of them are marked red; those are deactivated. So that's the overview of all the jobs that are there. And of course, there is the agent log. So it logs all the running jobs and their outcome. And you see here on the left, everything is green. So that succeeded every time. That's a good information in the first place. You see that's the timestamp. And you see in the back in the duration column. But if I ask you, where was it that it took longer than usual? You have to search the column up and down. So let me see, it's about here where it took like 7 minutes. It's not easy to spot at one glance. And even think of that, that's only for like 4 hours worth of log, and you have to look at it very closely to find what's going on. So we have jobs that run longer, jobs that run shorter, but when they tend to take longer and longer, it's probably a problem. So that was where I thought you have to monitor not only the green or red state, but also the runtime of those things. Okay, and that's how this little solution came to be. One thing I stumbled upon is the defaults for the history log. So the defaults are it stores 1,000 rows for all the jobs altogether, and maximum 100 for any individual job. So if you think like a log backup that runs every 15 minutes, as we had it on the previous slide, that means you have 96 rows per day. So with 100 for any job, you can't even compare 2 whole days. So you have to play around with those defaults to make some sense of it. And in my situation, it made sense to put it to 5,000 rows for all jobs together, and 1,000 for any individual job. So that brings us into a state where we can actually get some information out of the log. You only do that once, and then you leave it running like that. Okay. Then next up, the databases, where to find the actual information. At first, I thought I'd look in the master database, but of course I was wrong. Master holds only the system level information of the instance. Yeah, just to line them up here, model, of course, is the template for every new created database. And then you got the MSDB. And that contains all the SQL Server agent information, which is what we need here in this case. It's also used by backup and restore, by service broker, database mail, and so on. Fourth system database, TempDB, of course. Yeah, the so-called public toilet of SQL Server. I don't know, was it Klaus Aschenbrenner or Brent Ozer? One of the two coined this term. Very nice. And there's a fifth database that's hidden, so it does not appear in the list of databases. That's the MS SQL system resource, which contains the sysschema objects. Now, if we take a look at the MSDB, we have, how many are there? 7 tables that are related to the job history, which is sysjobs. We only need that to have a readable name, and this is job history. You can have the jobs running on different servers. You can monitor the single steps, of course, going into more detail and so on, but we don't need all of that. Okay, Right. We need, yeah, as I said, this is jobs. Man need a job name because internally all the jobs are defined by a GUID and not a name, which is not very readable. It also has descriptions and categories. So if you want to build up on top of that, you can get more information out of that table. The sysjob history has the information about each run of a job step. And when we only look at step 0, it's the job outcome. So the final result of the whole job running. So that's where we can take the date and time, also the duration, and we can regard also the run status to see if it was successful or not. In that case, if it's 1, it's successful, 0 is failed, and you got some other statuses here which are not of interest so much to us. Okay, so the query is not very complicated. That's about all we need. We have the sysjobs table, join it to the sysjob history. As I said, the step ID 0 is for the whole job outcome. And then we get the name, the status, run date and time, and the duration, order it, and that's about all we need. So we have to make some sense out of that, of course, but we'll see how that works. Okay, let us just switch over to, where am I? The Azure Data Studio. I have a, let me see. Yeah, you should connect to some server, of course. There you go. So I have a SQL Server 2019 Developer Edition, and it says it runs on Linux, which is almost true. It's running inside a Docker container right on this machine, which happens to be a Macintosh. So that's also why I have the Azure Data Studio or not the SQL Server Management Studio. But that should be no problem. You can do all that stuff also in the Management Studio. But with the Azure Data Studio, of course, you can do it either on Windows or on a Macintosh or on a Linux system. Okay. So we're going to use the MSDB, and then let me see. There are the tables we've just been discussing where we fetch the information from. And from this point on, I'm going to fake just a little bit because I'm not supposed to remote into our production system when other people are watching. So I can't get to the real production data. What I did at some point in time, I just copied the relevant tables from the production, anonymized it a bit, and put this into a database here I called MSDB2. And so we can see what's in there. I got my sysjobs, like 24 jobs altogether. And you see here is the GUID that they are identified by, but we'll rather have a readable name like this, Phil, blah, blah, statistics and log file stats and whatever. Okay, so that's one table we need. And the other is the sysjobs history. That also relates to the GUID, so that you join it on the ID, but then you get here, step ID is the job outcome. Also, the message says, yeah, job succeeds, which is run status 1. And you got things like run date and run time, and so run duration, and so on. The format is a bit silly here. The date is okay, that's 2019, September 29th. The runtime is in hours, minutes, seconds, but without the leading zeros. So that would be like 0 o'clock, 25 minutes, so 25 past midnight. And also the duration, that's also hours, minutes, seconds. So that's not 5,500 seconds or something. That is 55 minutes, 47 seconds. Watch out for that. So you can't just take it like that. That's why the select query actually, let me see, looks a bit, yeah, okay, that's the actual query we need. Here we got the silly time and duration thing, and we do a little bit of casting and formatting. So it says now here the job called article statistic update, whatever that means, had a run status of 1, so it succeeds. It started at 2:45 at night, and it took like 18 seconds. Okay, so where was that? Here. That was where it said 5547, so that's 55 minutes 47 seconds, and it starts at 0:25 hours after midnight, right? Okay. So as I said, I have been looking into the R language, so I thought, well, how can I bring those two together and get some meaningful result out of that? Let me see. So I went to this one. This is the RStudio environment, which is the de facto standard for developing in R. Let me see. I have a brief introduction. Yeah, that's where the software doesn't play along. There you go. For those of you who never heard of the R language, it's a programming language for statistical purposes, for analysis, for visualization. It's used by the statisticians, by data miners, and the fancy people that call themselves data scientists. It's been around for over 25 years. It's been invented by two guys from New Zealand as a successor to the S language, which was proprietary, which was commercial, which was very expensive and not expandable and all that stuff. So they thought they could do it better and invented the R language. This is an open source, it's a GNU project, and you can have builds for all the mentioned operating systems like Mac OS and Linux and also Windows. And one of the key success factors, I would say, of the R language is that it's extensible through so-called user-created packages. Think of, well, extension libraries. Like if you're missing a function in R, you can develop it for yourself and then create a package out of it, upload it to a central mirror, a central repository, so that everyone in the community can use it afterwards. And that happens all the time. There are at the moment more than 17,000 packages available on the central CRAN mirror, which everyone in the community can use. When I did an R talk, it was like, let me think, about 4 years ago or something like that. It was maybe half that number. I think it was like 8,000 or 9,000 packages. So you see, it's a very busy community, which helps bring the language still forward. Yeah, there has been commercial support, of course, not only, but also by a company that was called Revolution Analytics since 2007, and they've been acquired by Microsoft some years ago. So, like always, if Microsoft is missing some competencies and can't build them fast enough themselves, they acquire a company. So that's David Smith and his troops. They are now part of Microsoft machine learning division or whatever it's called. And they bring us that stuff that makes it possible to run R in the SQL Server, use R visuals in Power BI, and things like Azure machine learning and so on. Okay, there are several IDEs to develop an R, but as I said, the de facto standard is the RStudio, which you will see in a minute again. There has been also a thing called R Tools for Visual Studio by Microsoft. So they try to bring you the functionality of the RStudio environment to Visual Studio, but that has already been deprecated again. So from Visual Studio 2019 on, you can't use it anymore, which basically tells us, well, use RStudio. Well, what else? Okay. Now in R, well, I'll start with the demo, I guess, and then we'll pack it together. So that's the RStudio environment. Just briefly introducing it. Top left, you got your source code window, which of course can have multiple source files open at once. Bottom left is the console, which is for interactive, or you can do simple or operations here, and it gives you a result here. Also, you can invoke the source code line by line, and it will give you a result on the bottom right here. We'll see that in a minute. We've got a small terminal window. If you need to do anything on the OS level in between, you can do that here. And relatively new is the job tab. If you have a long-running R script, you can start it to run in the background, and then you can, in the foreground, you can continue working on other stuff. Okay. Top right, the so-called environment. We'll see that any variable we create will be listed up here. There's a history window of the command history, of course. You got a connection tab for database connections, and you see I usually work with a SQL Server. And relatively new also here is a tutorial tab where you can start different tutorials from within the environment to learn more about R and the RStudio. Bottom right, we have a multi-purpose window which has a small file explorer. There's a window for plot output. That's the list of the packages that I mentioned. Those are the packages that I installed on my machine, so which I have used before. There's a help window for RStudio and of course for the R language, and every package you install has to bring its own help pages. So you can call the help function for anything you see, and you get some information what's behind it. There's a viewer window that's for interactive stuff that doesn't go into the plot window. Okay, so, and I have one script prepared here. We have to load some of those libraries first, like a library for the database access and a library to do some data transforming, data tidying, and a library that does the plot output. Okay. Then I set my database name, which was the MSDB2, as I saw, and I open a connection. And you see, once the connection is open, it already shows me all my databases here, and there's the MSDB2, and inside that are the two tables with the data we need. Okay. Then I just paste the SQL statement into a string variable, and that's something you can see in the environment already. Like here, we got the SQL statement, I got my database name, also the connection that counts as a variable. Everything is listed up here. And then I fire my query against the database and store the result in a variable called jobHist. I bring it into a proper format, and then I can just show it here. And that's what we get back. Of course, that's what we saw before. It's the job name, the run status, the date timestamp, and the duration. And for our purposes, we'd rather have the duration in just in running seconds, not hours and minutes and seconds. So we do a little bit of mutating the data. So that's just the seconds then down here. Okay, and then we can go out and start and then do a first plot, which is very simple in R. Usually it's a one-liner. If you take a closer look, I call the plot function. I tell it to get the data from this variable, and I say, well, I want my run date time on the x-axis. I want my run seconds on the y-axis. Do me a favor and group it by name, so all the points that belong to one job outcome are connected, and give him different colors. And I want to see a line graph. So that has popped up down here, and you see there's one line here up the top dominating it all. Let me see if I can zoom out. Which one is that? In blue, probably it's the maintenance database. Yeah, that takes some time. And of course, all the others are down here. The things that run very short, a couple of seconds, you can't see very good what's happening there. So we do one trick that's called facet wrap. We'll just call it there, and you'll see in a moment what it does. There you go. Now, what that does, it divides the graph into, we'll call it subgraphs, so that every job gets its own little graph. So we see I've got like 16 jobs that had any job history. So a couple of them were deactivated, and a couple of them didn't have any history. And I let the axis float free. That's very important, because if you do that, you can have, like here, this one has runtimes between 0 and 1 second. Everything here is in seconds, by the way. So if the dynamics NAV object changed, yeah, I'm working on dynamics NAV, you can tell that one runs very fast, and maximum it needs 1 second. So it stretches the y-axis between 0 and 1 second. The update of some article statistics, well, it needs maybe like 50 something seconds. And where's the big one? Yeah, here. The maintenance of the database, of course, that's a big job, and you can see that runs into 100,000 seconds. That's I don't know how many hours. So that each of the graphs has its individual, how we say, axis ratio. Okay, and also you can see down here the date axis also has individual settings here. Where it has date from September, it starts in September. Where it doesn't, well, it starts just where the data starts for the individual job, right? So that holds in principle the same information as the last graph, but of course in this way it's very much more readable, and you get the impression per job, how did it perform, and what's the runtime. Of course you can't compare them to each other. Like if you see here up top, that's 9 seconds. If you look here up top, that's 100,000 seconds. So that doesn't make any sense, but each on its own, it's very clear to see, I think. So the next step would be to, let me see, we add the job outcome. I added the color red and otherwise in black, so we see where the job did not succeed. It's displayed in red, and then let me see. Okay, we can zoom in here as well, so you can see we have 2 jobs that have red parts. The one down here that almost always fails. Yeah, it always fails. It's all red. That's not very important, I guess. And there you see just in between something went wrong with this one. Yeah. So there was maybe in 1 week there was I don't know, a missing connection or something like that. So it failed here, but otherwise it was okay. And then we go on and add that trend line. So I was a bit lazy, so I left it to the plot function to actually add that trend line, because once I say I want that line graph, and in the next line I say, give me a smoothing line, which actually is a trend line sort of, and it should follow a linear model. So a linear regression line, and it's taken over by the plot function to imply that. Okay, let me see. There you go. So the blue line now represents a trend, or if you want to say a regression of the development of the runtime of each individual job. So you see, like here, that goes up just a little bit, and here it goes down. So yeah, that one goes up even more. If you see this, that goes down. Of course, you can tell that with spikes like that, it goes up. So, but sometimes it's not so well to see. Like down here, maybe for the blue line, you can tell it goes up down just a little bit. So it takes less time when it goes on. So that's not very dangerous. If you see this one, well, of course, it's a bit wild starting there, going up, but you see the tendency here is rather strongly going up. So you would have to have an eye on this one, how it develops over time. Also this one. Of course, it has some spikes here, but the tendency overall is going up. So that needs, let me see, the tendency is for it to come out at like 5,000 seconds. And if you count them all together, it might happen that the night becomes too short for all your night jobs. And so you have to watch out which ones are in the tendency of needing longer and longer. And then you have to dig in deeper and probably see what they are doing and then why they are taking longer. Okay, but this is just the linear model. You can have different models. One other is the so-called loss function. I'll give you that also. And once it's there. But that strongly depends on your data. You see, it follows a bit more the actual data. So where there's a spike, it goes up, and then it tells you, well, actually it's going down again, right here. Okay, so where does it go up anyway? Almost nowhere. Well, maybe here from down there it goes up just a little bit. Otherwise, we are on the safe side. It does not always make sense. Like if we look at this one, when there are very few data points, it doesn't always play nicely because you see here it has a minimum at a negative time, which of course is not possible. Negative runtime, it can't occur. So the loss model does not fit here very nicely. Otherwise, also, if there are very few data points, like maybe here for the index method, it just follows the line, of course. So it's a trade-off between having just the linear model, which of course always is a straight line, and some other model that may follow it a bit better, but you have to be careful about which model you choose here. Okay? All right. So I'll close my connection from here and hopefully, no, it doesn't. Why does it not? There you go. So to wrap this up, we have to start calling the package we need, like for package for our database connection, the package for the plot function, and so on. We create a connection, we run a SQL query from within R, and then we modify the date and time and add some color coloring. And we call the plot command. And here the faceted plot with free scales, that was the winner, because otherwise we can't see anything. We can't really get detailed information if we have one job that takes extremely longer than the others. Okay. Yeah, we can add the coloring for the status, so we see if it's red, something is still wrong apart from the runtime. If it's black, everything's okay. And we added the trend lines, either following a linear model or others. So now we have to bring these all to the SQL Server, because of course you don't want to always fire up the RStudio environment. And let's see, what do we need? Where's my Data Studio? So here we enter where we stopped off before. We ran that query and we got the data back. So if you want to run R scripts inside SQL Server, that is possible since a couple of editions. I think it started in 2016, not sure about that. And you have to have the integrated R services installed, and you have to configure the external scripts to be enabled. That's something you have to do once, and then forget about it. Where are we? Come on. I'll call that again, even though I did it before. So you just say enable the external scripts, reconfigure, and then you have the possibility to call this integrated stored procedure, which is called SP execute external script. It takes a couple of parameters. First, the language, which in our case is R. It could be also Python, and it could be, the newest versions take, what is it, Java or JavaScript, one of the two. I always mix them up, sorry, I don't use them. So we stick to R. Then you insert the actual R script. So for just trying out if it works, I'll take this one. I take the input data set and just put it through to the output data set. Then we have the input data. In this case, I select one and in the column called hello. And then we have a result set that says, yeah, give me that column hello. It is an integer and it's not null. And if we call this beast here, what happens is, yeah, the R service gets started and the little R script is passed to the launchpad, and that's the result. So there's one column called hello, and it's got a value called one. It's just to see that the R service is actually running in the background. Okay. So then we want to do some real action, of course. We have this select statement that we saw before. We store that into a character variable, and then we got the actual R script here. We'll also store that into another variable. I call that R script. Yeah. So it's like before we call the libraries. Of course, we don't need the DBA because we are inside the database, and we have a select statement to give us our data. So we don't need the DBI library for the database access. But we still need the other libraries for the data tidying, prettifying the plot package. And then we'll do anything we had done before in the R script. You have to be careful though, if you have the single quotes, you have to double quote them. And then there's some additional stuff here because you have no way to directly show the graphic output in Azure Data Studio, and especially not in SQL Server Management Studio. So what I do here, I start here with saying I want a PNG graphics file, and that's the actual, that's the command to store it afterwards. There is a different way of doing that. I come back to that in a minute. So we got our R script, and then we can call the so-called SP execute external script. Say, hi, our language is R. My script is in the R script variable. My input data comes from the select statement that's in the input query. And to get some output just to see that the script is running properly, I have defined an output column, and I just give the file name back. Okay. So then we have to call all of this together. Where am I? Starting from there, and execute. And that takes a moment, and it gives me back the file name here. And with the Azure Data Studio, I can actually open the file. Yeah, I've opened it before like this. That's something you can't do in the SQL Server Management Studio. And we've got the graph that we saw before in the RStudio, right? So with the linear regression lines here, we have the red parts of the graph where the job did not succeed. We got the floating axis here everywhere, and you can see the tendencies one by one of the runtime of your jobs. So that's almost all. They said, of course, well, you can go on from here. Let me see. Stay with me. Okay, so bringing it all to the SQL Server. That meant, yeah, configuring the external scripts. You construct the call to the SP, the store procedure that gives you the possibility to run R as well as Python, and let it be JavaScript or whatever. And you can directly use the SQL query, so the select statement for your input data set. That's why we didn't need the package for the database access. Yeah, make sure to mask single quotes, otherwise you run into trouble when you try to run it. And then you call the PNG and the dev-off. Alternatively, there's the ggSave function. I think I had that. Where am I? I think I had that, yeah, commented out here. There's ggSave. In principle, that's a more modern way of saving your graphics to the file system. But in my case, I didn't succeed to get it to produce the same output. When you use it with your standard parameter defaults, the graphics are too small and the text is too big. So you have like a very little tiny graphics and huge text blocks around it. So the proportion is totally off. If you do it like this, you give it some parameter like width and height, yeah, it does what it should do, but then the resulting file is about 5 times the size as it used to be in the other variant. So I didn't find the optimal way to use the ggSave actually. So maybe if you want to play around with it, maybe I haven't found all the right parameters. That may be possible. Okay, so I have to do it twice all the time. Okay, ggSave alternatively. And well, we're rather fast today. So what did we see? Well, the accidental or the proper DBA tasks, of course, include monitoring agent jobs. It is what it is. I found it better to have a graphical overview than to follow endless columns of numbers. Like you remember finding where the time was off, the runtime was off. And think about if you got like, if it runs every 15 minutes, there's almost 100 entries for the day. That's you can't really spot anything on the first side. So, well, it's true what they say. The picture says more than 1,000 numbers. Okay. Then, yeah, I wanted to combine my SQL and my R skills to have a, well, proof of concept, a little prototype to use some R for something useful finally. And yeah, if you combine it this way, there's a first result relatively fast. Of course, you can twiddle around with it and think about doing other predictions than the linear model, as we saw. That may or may not work. It depends on your data. So you can play around with it, and maybe you should. Yeah, RStudio definitely is better suited for developing and debugging. Of course, you can just enter the R script into Azure Data Studio and try to run it. But that's not really comfortable to do in terms of debugging or just following what values are in your variables. The error messages may not lead you to the right spaces. So for developing, I still use the RStudio. Once the script is fine and it runs okay, you can just copy the whole thing over and just adjust the input of your query where it comes from, and then you're in the business. So yeah, that solution should run on all relevant operating systems like Windows, Mac, and Linux, and regardless if it's at the Data Studio or SQL Server Management Studio. In the Management Studio, you can't really show the graphic output, but we'll get to that in a minute. And none of that requires extra dollars or euros to be invested because they're all free tools. Right, like either the SQL Server Management Studio that comes with a SQL Server or the Azure Data Studio, you can download it for free. The RStudio and the R environment are available for free also. So it doesn't cost you any extra money to play around with that and get going. Okay, so let me think. In October, I gave this talk in near Munich in Germany, and at one of the first slides where I had 24 jobs, and I asked the folks in the audience, well, how many jobs have you got running? And it was like 50, and all hands went up. And I said like, well, 100 or more, and still all the hands went up. And then I asked the guy in the first row, I said, yeah, come on, just tell me how many you got. Well, around 700. And I was like, ooh, you will not be happy with that solution. So, of course, if you got like hundreds of jobs running in one instance, yeah, it's not the solution like it is that you can use, of course. So for environments with a bigger number of jobs, you should in beforehand group your jobs and do group-wise analysis. So maybe by the type of job, maybe you got lots of backups running. You can just regard the backup jobs and then data export jobs and stuff like that. Or you group them by person responsible. So if one guy is responsible for the backups, you can show him all his jobs. If one lady is responsible for the data exports, let her just regard her jobs and so on. Well, of course you can cut off some of them. Like if the average runtime is like around 5 seconds, maybe it's not that interesting if it takes 10 seconds sometimes. If you got a job that runs 4 hours and suddenly that takes double, so 8 hours, yeah, that may be the trigger where the night is too short for all of it. But that's a matter of the individual constellation you have there. There's a trade-off, of course. Or even you can regard the degree of growth in runtime. So like when a job slowly needs longer and longer, that may be okay. But if it, let me exaggerate here, if it doubles the time every week, you should first look at that one. But to see that, of course, you have to be not as lazy as I am and leave the trend line to the graphic. You have to pull out some of the data mangling and do it up front before you generate the graphics. But that's perfectly fine to do in R. So you have to do some analysis up front, how the development goes of the runtime, and then filter by that, and then show maybe the jobs that tend to take very much longer. Okay. And well, of course, it's not a final solution. Of course, you can automate the generation of this analysis graphs by creating your own job, of course. Yeah, just storing the graphic somewhere in the file system is, of course, not enough. You may want to send the results per mail, maybe to the responsible staff. So in the morning they get a mail with that graph and see, oh, there, you have to look into that. Maybe even you can set up a dashboard. So depending on if you're more in the SQL Server world, you may have Power BI already in use. And integrate that graphic into a dashboard. Or if you are favorite on the R side of things, there's the so-called Shiny framework that is also freely available. Actually, it's a package you can use to design even interactive dashboards and things like that. So maybe you can use that to even drill into the actual data and so on. Yeah, and of course, you don't have to just tie yourself to the job outcome. If you have data for backup and restores, maybe that's interesting also. If your backups tend to take longer and longer, that may be even more critical. Or your DB maintenance, as we saw. Well, yeah, if you have a big database, the maintenance takes a while. But still, if that runs out of hand in terms of runtime, it may be a wise thing to watch that up front. So, yeah, improvements, that's lots of fields, lots of things to do. It's not a final end solution for the monitoring here. Right. Yeah, some more information, well, about the system databases, how the agent tables work together on the Microsoft document side, of course. You can download R and other packages from the so-called CRAN Mirror. The RStudio IDE is from RStudio, yeah, but there's a free version available. They also have paid services. Well, if you go on really deep into that, take a look at their site. And if you want to know more about what's machine learning, what's the R service, how does it work in the SQL Server, there are documents for that also. And with that, I'm through actually. So thank you for your time and your interest. I'll be uploading this file and the demo script to this address, and also if the Data Saturday organizers would like to have it or post it somewhere, I'll have it there as well. There again, there's my social media data. If you want to keep in touch, please do so. And well, we've got a couple of minutes time. Are there any questions?